Good morning. Welcome all the participants in the room here, and of course a big welcome to the audience joining us online. So I will explain a little bit why we're here. So we work for the Data Science Campus in the UK for the Office of National Statistics, and we want to thank you so much for inviting us today to share about machine learning. My name is Eric Deben. I'm the head of international programs, and here with my colleagues Alison Bailey, and later on we also see my other colleague Alex Neuvert will deliver some technical sessions. And then online we have some sessions from the different speakers that we've been working on, and also we have In-Kyun Choi from the United Nations Economic Commission for Europe will also do a big session around the introduction. So why are we here? As we heard yesterday, the importance of international collaboration for advancing the adoption of big data into official statistics. I mean, we really want to support the launch of the regional hub for the Middle East, North Africa, what we heard yesterday in the really impressive opening event. And also, we want to support the UAE in more general around data science and further development. And of course, I want to extend a big thank you to the Federal Competitiveness and Statistical Centers. A big thank you to Latifa, Hatim, and the rest of the team for making us so welcome and putting this big organization together for us. So I'll explain now a little bit about the running of these sessions today. And this is really the launch of our 2022 program. How we started this 12 months ago. We're going to now in year 2. It's called the ONS and Machine Learning 2022, very much again in collaboration with the United Nations Commission for Europe. What I really want to emphasize is like 3 main points. We want to talk a lot about collaboration, as what you will learn today. We want to talk a lot about research. How do you actually bring the data science together into this? And very much on partners. We can only do this if we really join this all up together. And today we'll hopefully give you a further and a better vision around the ambition for machine learning and how we can move into the goals to actually to start delivering that, because operationalization of machine learning is a big step forward for producing official statistics. So now I'll briefly run you through the agenda. So what can machine learning offer as a service to accelerate the production of official statistics? We need to work with experts from NSOs all around the world. And we need to really explain the value of machine learning. The work we can do with it, we need to look at use cases, which we explain a lot in the research workshop we do later. And we also need to look at the different applications we can apply for that. So this session this morning, which will run for the next hour and 15, we're going to do it in person and online. It will be mainly led by Alison sitting here next to me, and of course In-Kyun will be dialing in from Geneva. I mean, the rest of the day, this will start 10:45 UAE team. We really going to look at what Alex and Klaus will be support from the UK around machine learning. So we're really going to go into the technical specifications. How can you apply this? We're going to have a morning session for beginners, and for you and online, very much welcome to join us for that. And it's really to demonstrate the capability of ML and also give you some basic principles how you can start. And then after lunch, we'll have in person, we have the 2 coffee and coding sessions. So people in the room here will actually get hands-on experience working with Alex, and again, with further support from Klaus back in the UK. And what we're really looking to do is like to see how ML applications are developed, but also very much how that can be used. We will do a big deep dive into the applications of ML algorithms and practice together with Python codes to do some real example coding there. If you want to look more into the research part, then you will join us upstairs. So this is in an in-person workshop only. And we really then actually going to unpick like how to understand the business needs. We're going to look at integration. We're going to look at the quality framework for official statistics. We're also going to look at actually building an example proof of concept. So you can take away back to your organization to really start applying that and actually make that proof of concept. So it's very much like an agile way of delivering this. So you can really almost in a matter of weeks, and especially a few months, you can establish, is this going to work for the certain project that I have? And also what I'd like to encourage for those in the room is really that we have from 3 till 4:30 this afternoon, we have like drop-in sessions. So we're very happy to welcome anyone to really speak to you, to give you more background of what we've done in the UK and what we've done internationally and how we can make sure that your organization is part of this journey. So with that now, I'd like to hand over to Alison.
Hello, everyone. Very good to be here. Welcome to everyone in the room and also online. My name is Alison Bailey. I'm the coordinator for the ONS UNECE Machine Learning Group 2022, and I'm delighted to be with you here today. So machine learning is a relatively new method in official statistics. Many national statistical organizations are still exploring its potential and testing its feasibility for their work. So there's lots to learn from each other, from different national and international statistical organizations who are experimenting and looking into the potential of machine learning. So that's what we've really been doing in the ONS UNECE Machine Learning Group. For the last 3 years, we've been working together. We're now 250 members from 33 countries, and we've been conducting a lot of pilots and proof of concept research, which we are making available and sharing online for the wider statistical community. So today what we want to do really in this first session is to share with you what we've learned so far in our group about the benefits of machine learning, and also give you a few illustrations from different national statistical organizations about how about how machine learning can be applied and used in different statistical organizations. So I'm very glad to say that we've got some of our expert speakers from the ONS UNECE Machine Learning Group here online to speak to you today and tell you about their research. So with that, I think if we can just move over to the slide on the agenda. And yes, so that's just a sort of run through really of the agenda for today with the, yeah, we're just the wrong agenda. Just sorry, having some technical problems with the clicker here, which we'll try to resolve shortly. So yeah, so here's the agenda for for the next hour and 15 minutes. And I'll hand over now to my colleague, In-Kyung Choi of the UN Economic Commission for Europe, who is sort of lead coordinator alongside me for the machine learning group. And she is going to give you an overview of machine learning and its benefits for official statistics. So I'll hand over to you now, In-Kyung, let you share your screen, and yeah, over to you.
Can you confirm if you can see my slide, okay?
Yes, we can see it. Thank you. Thank you.
Okay, thank you. Yeah, so good morning, everyone. Welcome to the first session of today's program that looks to be very interesting and informative. I really wish I could be there with you in person. So as a start of this session, this presentation aims to provide a general overview about this topic of machine learning for official statistics by answering these 3 questions. What is machine learning, and why there is such buzz around the machine learning right now? And of course, most importantly, how machine learning can help official statistics. There are several definitions of machine learning, but the one that I like to use is this one. It is a field of field of computer science that uses a statistical technique to give computer systems the ability to learn with the data. Now, this may sound a bit technical, but the important part is this, the computers learn with the data. For example, let's say we have a text describing the circumstance of work-related injury of someone like this. I cut my fingers while chopping vegetables. And you have to predict whether this person is a cook or a statistician. We as humans can guess this person is much more likely to be a cook than a statistician because we know that from our lifelong experiences that chopping vegetables is related to the work of a cook rather than of statisticians. But machines do not have these experiences. But if machines are given a lot of data that describe work-related injuries of a cook or a statistician like this, they can figure out patterns associated with each job. So in this way, what humans know from experience, machines can learn from data. One common question raised when it comes to machine learning is what is the difference between machine learning method and so-called traditional statistical methods? Because a statistical method, they are also based on data. Actually, the line between machine learning method and statistical method is not like a black and white. There isn't a universally accepted grouping. But one way to look at this is in terms of the purpose of a method. Often traditional statistical method is used for estimation of a population characteristic, like whether the level of a household income affects the education level of a child or not. So we are interested in understanding the population parameter per se. But for machine learning, it is more about prediction at individual level. So it doesn't care what goes on behind. It just wants to predict an education level of a child given household income. And because of this, there is a tendency that what people often call as machine learning methods are more complicated than the traditional statistical method, because what is important for machine learning is to get the prediction right. And as an illustration of how machine learning is different from traditional methods, I will compare linear regression, probably most well-known statistical method, with the gradient boosting method, one of a very popular machine learning method. And let's say we have a data like this with the variable x that you want to use to predict another variable y. And linear regression draws a line, minimizing the errors between the observed value and predicted values based on this line. Now, here is how gradient boosting works in a very simplistic way. You'd not get a straightforward analytical solution like this in the linear regression, but it gradually learns as it goes. So you start from a very simple line like this, and then you calculate the errors, and add one step function that reduces this error. Then you calculate the error from step function, and so on, to create a more complex composite model like this in the end. Now, going back to what I mentioned earlier, how traditional methods focus on estimation and machine learning methods focus on prediction. If you look at this linear regression line, you can give a very neat explanation about what's going on between variable x and variable y. But on the other hand, this kind of explanation is a bit more tricky in this step function because it increases this much here and then twice more here and then reduces here. So it's more difficult to explain. And this is still a very simple example of a machine learning model. So with a more complicated machine learning model, it is more difficult to give a straightforward explanation as it was the case for the linear model. But still, this step function can be much better at prediction because you have a much more flexibility to optimize around this data. Now moving to the second question, why is machine learning so popular these days? Why is it drawing such attention? There are a few factors that contributed to this. First is the data. In machine learning, machines learn from data, and since we are living in a data-saturated world, there are only so much data for machines to learn. Also, there has been a lot of the advancement in the theories and methodologies. And this allowed us to analyze not just the numerical data, but also textual data, imagery data, and audio and video data in a very fast and efficient manner. Also, there has been a lot of hardware side developments. So processing power of computer is getting stronger each year, and the cloud computing is becoming more and more accessible. So powered by these developments, machine learning has made a lot of progresses. So now it can write or paint and drive like humans. And as mentioned earlier, because machine learning is very good at individual predictions, it is really widely used by private companies to provide tailored individual services to their customers. What does all this mean for official statistics? Because the statistical offices are not a provider of mass tailored services. They're providing official statistics that are basis of governance of a country or running of a business. And as such, there are some constraints, rules, and principles to follow. Then how machine learning can be used for official statistics? And this is a very question that was asked by these two international initiatives that Alice mentioned just before, that conducted in the past 3 years. And they produce numerous pilot studies and papers. So what did they find about the machine learning for official statistics? How can machine learning help official statistics? It is said that any industry with a very large amount of data, so much that humans cannot possibly analyze or understand it on their own, can utilize machine learning. And National Statistical Office have a vast amount of data and known for their expertise in data analysis or data management. So there's a really great potential that machine learning can contribute to the work of a statistical office. Here, I want to clarify one point that this large amount of data does not necessarily have to be so-called big data. It is true that machine learning is very useful for big data and can be a must for certain type of big data. But big data is a type of data and machine learning is a method to analyze this data. So big data can be analyzed without the machine learning, although it might not be so optimal. But more importantly, machine learning can also be used for non-big data. So machine learning can be used for medium-sized data or ordinary survey data that you have already in your organization. So where can machine learning be used for production of official statistics? At a very high level, statistical production can be simplified like something like this, where you have an input like a raw data set where user needs, and then you have an output on the other side, like a finer data product, such as the indicator or estimates and so on. And when it comes to machine learning, people are often concerned that it is going to be too big change. They're worried that if we replace this existing way suddenly with the machine learning, that would be too much. But production process is not simple like that. So it consists of a series of a lot of activities that require different people and expertise. And machine learning can be used in several ways in this production process, and it could be much less disruptive than some people might fear. For example, one of the most popular machine learning application area these days is around this classification and coding activity. This is where we classify responses that were collected into one of the standard classification systems, such as COICO. For example, if we have a textual description of a product like orange juice with 100% pulp, this can be categorized by COICO system as a fruit juice. And by the way, the coding and classification happens not only for survey data, but also for big data like web scrape data. You will see more example in later. Because if you want to calculate CPI or inflation rate, you still need to be able to categorize this web scraped product into certain categories. And traditional way of carrying out this coding and classification is either based on very complex, very difficult to manage rule-based system or manual coding. So humans read this description and assign code. And you can imagine that this large part of this manual work is quite tedious, but still really resource intensive because the people have to spend so many hours on it. But with the machine learning, this can be done automatically because the machines can now read and understand text like a human, at least to a certain extent. So it is not that we suddenly produce a nationwide inflation rate or CPI by machine learning. We are changing this part of production that used to be done manually and used to require a lot of resources. And similarly, other parts in the production process that require repetitive or manual tasks, such as review and validate or edit and imputation, can benefit from automation from machine learning. And the benefit of automation is actually probably much more prominent when it comes to big data. In this pilot study from Mexico, they used the satellite imagery data and machine learning method to produce urbanization index during non-census years. And satellite data have their own benefits, like they have a very high temporal frequencies and high spatial resolution, but it is still really big data. So for Mexico, there are almost about 2 million grid cells covering their territory, which is really a lot if humans have to go through each cell and decide whether that cell belongs to urban area or not. So what they did was that they used human experts to classify 40,000 cells, and this is about 2% of the entire data set. And then based on this data, they let machines to figure out what image patterns are associated with the urban area and rural area. And then machines classified the rest 98% of the cell. And this is actually a typical procedure when you use the supervised machine learning for automation, which is a popular type of machine learning these days, whether it is a big data or non-big data. So humans first classify small subset of data, and then machines learn from this data set and they classify the rest. So you see, it is not that the machine learning will completely replace a human. Humans still need to provide input for machines for them to learn. But since the majority of the work can be done by my machine, the entire work can be done more quickly, and maybe people can spend their time on more high value activities. So in the last few slides, I showed how machine learning can be used for automation. Now imagine we want to introduce machine learning in our office. Then how do we know machine learning will be better than the existing way? And it is not just a comparison between machine learning versus existing method. There are also many machine learning methods out there. There are simple ones like logistic regression, but there are also very advanced ones like a deep learning method. Then how do we know which one to use? And this is where the quality comes into play. We want to use machine learning only when it helps increasing the quality of our work. And this is quite complex task because the quality in official statistics consists of many different dimensions and area. So the quality framework for statistical algorithm, the framework developed by machine learning project team in 2020, proposed to consider these 5 quality dimensions when it comes to machine learning. And in the next few slides, I will share what I have observed the basis on these 3 quality dimensions. As you might expect from slides before, machine learning has shown great benefit in terms of timeliness. For example, here, Australian Bureau of Statistics used machine learning for address registration. And traditionally, it took them 5 days for humans to process 1,000 images. And with the machine learning, they can process 850 times more images for the same amount of time. And obviously, it takes time to put in such machine learning solution or system in place. But once it is established, you can finish the work few hundred times faster. The second quality dimension is accuracy. And I think it's probably the precondition of using machine learning at all. Because no matter how fast machine learning can produce results, we wouldn't want to use it unless it is accurate enough. And when comparing machine learning with the legacy way, machine learning may not increase accuracy as dramatically as it was for timeliness, but it is comparably doing well as traditional ways and sometimes even better, like shown in this example from US Bureau of Labor Statistics. But machine learning is not about good things only. There are problems unique to machine learning, one of which is explainability. Explainability is ability to explain how the machines make certain decisions. Machine learning methods tend to be quite complex, so some people call them black box because it's hard to understand what is going on inside the machine. For example, this kind of a deep neural network, it is a new network of numerous connections and parameters and so on. So it is quite difficult to explain why machines chooses one category over another, at least in a human understandable way. For example, if you give this image to someone and ask the person to decide whether this is a residential building or not, the person will probably say it is not residential. And if you ask why, the person might give you some logical explanation, like why there are so many flags in front of a residential building, or this building doesn't look very practical to live, or I've been to Geneva and I saw this in the UN, so it's a UN building. But machines don't give explanation like this way. There is a bunch of numbers, parameters, many things happening inside, but machines does not explain why it think this is not residential, at least in the way we readily understand. And being able to explain why a machine makes a certain decision is becoming very important in context of ethics, but also for the model diagnostics. So one might need to find some balance between highly accurate but hard to explain model and the somewhat accurate but easily explainable model, and compare between different methods in a holistic way. So that brings me to the end of my presentation. I want to conclude this presentation with a few final highlights and remarks. First is that the machine learning can be used not only for big data, but also for non-big data. And second is that there are very much advanced machine learning methods out there, like the ones that maybe Google or Facebook use. But we find that the simple machine learning methods often work just fine. So it is recommended that you start from simple models like logistic regression and gradually move toward more advanced models as you gain more knowledge and expertise with the machine learning. And the third is that depending on use case, you want to put different emphasis on different quality dimensions. The explainability dimension that I mentioned before, in some cases, you might not give too much emphasis on this dimension. Like in the example when machines are used just for assisting humans and the humans make the final decision. So it really depends on use case where you how much emphasis you want to put on the each quality dimension. And lastly, sharing and collaboration has been shown to be really helpful in facilitating machine learning. We started the machine learning project in 2019, and since then I saw many people benefit directly from sharing programming codes. And it's not just about sharing programming codes. Machine learning is a still relatively new field. So simply knowing examples from other countries that worked or that didn't work can already give you really good hint which area of machine learning, which area of your work that machine learning can be applied or not. So as Eric and Alison mentioned, we have a machine learning group 2022, just starting soon. So I would like to take this opportunity again to invite you to join this community. And we have this dedicated wiki space for machine learning for official statistics. And we have a publication coming soon that summarizes these experiences and lessons learned so far. So please stay tuned for that. Yeah, and that is the end of my presentation. Thank you for your attention.
Thank you very much, In-Kyung, for your excellent presentation. And I think that's a very important point about machine learning, that it's not there to really replace human role in statistical production, but to actually help focus their time on more high-value activities. So now we've had that sort of high-level overview of the benefits of machine learning, we're now going to look at some practical examples that come from our ONS UNECE machine learning group of how machine learning can be applied in practice in the work of national statistical organizations. So I'm really delighted that we're joined online today by 3 of our expert members of the group who have been conducting pilot research studies. And we're going to hear from them now about their work. And I encourage you to start thinking about questions for In-Kyung and also for our presenters. Please leave them in the chat, and also we'll come around the room at the end of the 3 presentations to ask for your questions, feedback and responses. So with that, I'd like to move to our first speaker, Dr. Ari Wijayanto, he's the head of the Statistical Computing Research Politklinik Statistika Indonesia, and he's going to be talking to you now about some of the really interesting work he's been doing on satellite imagery to map poverty. So Ari, I will hand over to you, and please share your screen, and we look forward to your presentation.
Thank you, Alison, for the time as well. I hope you can hear my voice and you can see my slides right now.
Yes, we can hear you. Your slide looks grey. It's a blank grey screen at the moment. Yep, we can see your title slide now.
Okay, great. Okay, thank you for the time. Good morning, everyone. Greetings from Jakarta, Indonesia. My name is Ari Wahyu Wijayanto from Statistics Indonesia, BPS. I will be presenting one of our big data team result on machine learning use cases to support the business needs in our statistical office. That is the remote sensing approaches using satellite imagery for poverty mapping in Indonesia. To begin with, let me briefly introduce the concept and definition of poverty that we have been using in Statistics Indonesia. To measure the poverty in Statistics Indonesia, we use the concept of ability to fulfill the basic needs, that we can call it as the basic needs approach. And we use this approach to define that the poverty as an economic inability for someone to meet the basic foods and non-food needs by measuring the poverty line on food and non-food. So the poor are the people who have an average monthly per capita expenditure below the poverty line. And we can measure that the poverty line in Statistics Indonesia, we measure as the value of spending on minimum food needs that's equivalent to 2,100 kilocalories per capita per day. While the non-food poverty line is the minimum value of someone spending on housing, clothing, education, health, and etc., other non-food basic needs. In Indonesia, we use this kind of method since 1998 so that the calculation results are consistent and comparable from time to time. And if we talk about the poverty database in Indonesia, we quite understand that our government has a main target to eliminate the poverty in our country for sustainable development goals, and we hope to reach that by 2030. However, the establishment of a complete poverty database at a national scale is very costly. Recently, we have an available household level poverty data at national scale at only a certain year. For example, in 2005, 2008, 2011, and the latest one is in 2020. 2015. That's because it's very costly to conduct the complete poverty database at a national scale in a household level. We have also the poverty data estimation using the biannual household socioeconomic surveys that are only available up to the regency or municipality level, not so granular enough. The advancement of recent studies suggests that we may use the satellite imagery as an alternative to measure the poverty distribution. For instance, we may use the nighttime light as an alternative proxy to map the distribution of the electricity coverage in a certain area, the infrastructure in a certain area, as well as the economic activity at night. On the other one, we may also use the daytime satellite images to extract the build-up or building distribution on a particular region, the geospatial infrastructure, as well as the economic activity in a particular area at a day. This has been introduced by several literature, such as Chen and Nordhaus in 2011, Henderson in 2012, and Ivan in 2020. They introduce how we can utilize this satellite imagery to support the poverty mapping. In this case, we aim to evaluate whether is it feasible or not to estimate the poverty spatial distribution as well as the wealth index development using this satellite imagery and geospatial data. What we would like to achieve is we want to enhance the currently costly poverty estimation so that it can cost effective, more granular, and more accurate of our current poverty statistics. If we talk about the machine learning techniques, most of the spatial data, for example, the poverty statistics in using satellite imagery, it has the big data properties. The geospatial analysis, we usually use this one to process the well-defined algorithm to extract a certain information, geospatial information from a certain region. This machine learning technique has been used a very long time for the geospatial field. We also really lucky that recently the emergence of new types of spatial data are coming from increasingly diverse data from acquisition methods. For example, from the mobile phone data, the point cloud, the social media, and SAR, and so on. It increase and give us more opportunity to extract the geospatial data for this kind of use. There are many potential data sources that we can use to map the poverty mapping. As I mentioned previously, that we may use the nighttime light as an alternative proxy to map the distribution of the electricity coverage, the infrastructure, and economic activity at night. So we use the publicly available data from VIIRS satellite. This is in the nighttime light. And we use the daytime from two different satellites, that is the Landsat 8 and Sentinel-2, that both are publicly available with different resolution. And it can give us the daytime satellite images. To make it work, we combine both of the daytime and nighttime light satellite and extract the feature from it. And we use the official poverty database and assume that this official poverty database has a ground truth level of a poverty level in a particular region. We use our own national scale official poverty database as a ground truth level, and we utilize these three different satellite images. To make it work, we combine both of the daytime and the nighttime light satellite intensities, and then we extract the feature, the geospatial feature, using the trained machine learning algorithm. In this case, we use the convolutional neural network, that is the ResNet-34. Using the extracted feature, we create the trained regression model using risk regression or support vector regression, and we map into the poverty statistics indicator. convolutional neural network that we have been using is part of the deep learning architecture that commonly used to recognize the feature on an object. For example, the picture or satellite images to be classified into a certain level. For the sake of the brevity and simplicity in this presentation, I will show one of our case study at the province of Yogyakarta to examine whether our prediction model is kind of feasible or not. On the left side, we have a nighttime light luminosity in the Yogyakarta province, while on the right side, we have an official poverty distribution. We can see that the capital of Yogyakarta province and its regencies has a greater luminosity intensity than its rural areas and areas outside the cities. So if we combine these nighttime light satellite images, using the rich in feature of daytime satellite images, we would like to model these satellite images to poverty mapping. This is the result of the poverty percentage by the prediction model using our ResNet34 model. And we can see that the result is, this is the raw one. However, if we take into account the population distribution, the results are quite good and in estimating the regional poverty. And we compare it with the official poverty distribution, and we can see that the RMSE is kind of like 8%, which is quite good for the this kind of CNN model and testing. And if we compare our prediction using the poverty mapping with both of the daytime satellite images, nighttime light satellite images, and rescale it with the population grid, we can see that the result of our model prediction, fortunately, is kind of quite good to estimate the regional poverty using the official national scale of household poverty, which is the RMSE is 8%. We have been, our big data team have been working hard to create the national scale poverty mapping with a huge area of Indonesia and more than 270 million of people. It is quite hard to conduct this work, to be honest. So this is the preliminary national scale poverty mapping of Indonesia. Please keep in mind that the province of Yogyakarta that I mentioned before is just a small dot here in this island. This is the island of Java, the main island of Indonesia, and we have a huge archipelago here, and the province of Yogyakarta is just a small dot here. In this preliminary national scale poverty mapping of Indonesia, we still use the only nighttime light satellites data without the daytime data, because we have currently the limitation on the computing resources. But however, in certain provinces, we have both of them, the combination of both of them for the daytime and the nighttime satellite images. In summary, the estimation model that we have been proposing for poverty mapping using satellite images has been implemented, and the model is quite capable to estimate the spatial distribution of poverty, and we have been conducted some ground checking to ensure that our prediction model using the satellite imagery at a certain location are correctly representing the local economic activity. So it can really measure the poverty in that certain area. We have several challenges right now. The first one, of course, we need the high performance computing resources to conduct this huge amount of data that we are handling so far. And this huge amount of data requires a very efficient processing pipelines, as well as we have to improve our prediction model into more accurate. And that's come to our mind at the moment is we have to incorporate some small area estimation model to sharpen our analysis into a smaller areas. And this comes to the end of my talk, and I would like to present one of the quotes from Nelson Mandela in 2003. Like slavery and apartheid, poverty is not natural. It is man-made, and it can be overcome and eradicated by the action of human beings. This is our process in Statistics Indonesia to overcome the poverty at our country. Thank you very much for your attention, and come back to Alison. Thank you.
Thank you so much, Ari, for your really fascinating presentation. And I think that, yes, that final quote really does sum up the potential. We have really exciting potential for machine learning to support the Sustainable Development Goals. So given time, what we'll do now is we will move straight on to our next presenter, but please do keep on sort of posting questions in the chat, also in the room if you have questions for Inkyung or Ari. We will have some time at the end before we close for the break. So with that, we're going to move from satellite imagery now to text classification. And I would like to introduce our next speaker, Dominik Dabrowski of Statistics Poland. He is consultant at the Experimental Research and Analysis Unit, and he has been conducting pilot research for us in the ONS-UNECE Machine Learning Group on text classification for real estate data. So with that, I would like to hand over to Dominik and ask you to share your screen. Yeah, thanks very much.
Thank you, Alison. Can you hear me well?
Yes, we can hear you fine.
Yeah. Okay. So I started sharing the screen. You should see my presentation already.
Yes, that's fine. You're good to go.
Okay. So I am Dominik Dąbrowski from Statistics Poland, and I'd like to, at the beginning, thank you for giving me the possibility to take part in today's meeting, and I'd like to thank for the whole year that me and my team, we could participate in this machine learning group project. Today I will present a short story of how we stepped into the machine learning, what were the problems we found, and why we should further develop those techniques. Well, why machine learning? The answer is simple: to get familiar with something new, to get ready to use it when the time comes. In our case, it all began with encouraging some people in Statistics Poland to search for new data sources and new methods which would allow providing more timely statistics, going beyond traditional territorial aggregation and going beyond a single domain. Our overarching ambition is to address life quality topics. So we had to think on how to expand research on socio-economic phenomena. The real estate internet offers data seemed for us as a quite good source according to compiling territorial data with some qualitative variables. So in the future, we plan to expand the initial real estate focused project much further to cover multiple data domains. In official statistics, we need to match to all the production and maintained results. So every change may be difficult, like Inkyung said before, and I guess that some steps of my presentation will also refer to things Inkyung said, and I would like to point out that regarding machine learning, it's not about seeing problems and breaking walls. I guess it should be more like seeing a challenge and building bridges. That's why we started our work with trying to be useful for traditional statistics. And at the beginning, we started out with meeting our CPI colleagues that are preparing consumer price index. we asked them whether web scrape data on real estate would be any useful to them, and it turned out it would be great for comparisons in the section of rental market. It all fortunately came with two favorable conditions, which facilitated launching this machine learning project. And one of the conditions was an experience gained in the first edition of the ML group, where two of our colleagues from one of the regional statistical offices in Poland worked on automatic classification of online shops products. The time they spent in the project was for them very inspirational and let them develop their skills highly. The second thing was that around the same time there was established an experimental research unit in Central Statistical Office where I work in this particular unit. We focus on creating experimental statistics outside the officially planned statistical production and merging the efforts of different regional statistical offices in this experimental different techniques working on big data and developing machine learning techniques. So first step of our project in the machine learning group was launching the auto-coding of real estate offers. And I guess that the step of data acquisition is the simplest part. But it needs, and in our case, it needed preparing some IT infrastructure like disk spaces, some remoted servers. Also, we need to set up a dedicated disk space, put it outside of our normal statistical internal web. And we need to work on some system of version controlling for scripts and programs. As we did not base our work on the data from statistical registers or statistical service, we had downloaded the data from internet real estate offers. We used an API connection of one of the portals, so it's the data we acquired is the same as we would web scrape it directly from the site. What we wanted to acquire were information on the presented apartments, the information on the price, area, number of rooms, and the full text description of the object. In the example on the screen, in this description, we have some information on the apartment's amenities. In the top, there are basic information on price, type of the building, number of rooms, and in the center and in the bottom, we have a full description of the object. We, in our project, focused on extracting information about kitchen type and security systems. So we focused on those two variables. To achieve it, we wanted to test auto-coding techniques. So what exactly we wanted to do was searching using machine learning techniques, the descriptions, searching them for the information about type of the kitchen and if there were any security utilities in the apartment that is offered. Next step after the downloading the data was the process of data cleaning, which seems really crucial and needs lots of time to prepare ideal set of validation rules. The cleaned dataset was the one on which we later manually classified the information. During our work, we encountered some problems referring to having unstructured data from internet. The data was written manually by people in the offers, so there were language mistakes and etc. The offers we worked very a lot, and some of the offers descriptions were very short. Some of them were extremely huge, so in some cases we had almost no information, and in others the data we had was mostly not needed. And as you can see in the table in the picture, the shortest description of the apartment had only 7 words, while the longest had almost 2,000. Some offers, especially in new investments, provided information on more than one apartment in one offer. So it is a problem for creating statistics on the apartments aggregated territorially and trying to take the content of this offer. You can see that this is the description of one of the offers, and in it it consisted of 14 different apartments. So this is something that we need to cope with, and still in our project there are many problems that we didn't overcome, but we hope that our further work will help us to achieve the final goal. Next example of some difficulties is the duplication of the apartments descriptions. So for machine learning algorithms, it is best not to have them in the data set. And in our set of more than 12,000 observations, we tracked more than 2,000 duplicated descriptions. So in some cases, the descriptions referred to dozens of apartments from one brand new investment. And like in the table, we had, this is just an example, so I needed to cut the long descriptions, and there may be 45 same descriptions with different price, different areas, but in the same location, in the same building. So we had to deal with the duplicates as well. Well, finally, we managed to auto-code our information using a logistic regression model and achieved results with the accuracy levels. So from all the descriptions, we extracted information on the kitchen type, whether it's separate or open kitchen, and if there is any security system used in the apartment. We taught the algorithm on the base of manually classified data. To manually classify the data, we prepared a dedicated browser app that helped us in a way. It highlighted keywords referring to information on referring to words on security systems. It highlighted, in our case, it in red, and the keywords of kitchens were highlighted in green. So it helped us to manage making manual classification. As we don't have the same data classified manually in previous years, we cannot exactly say how much time we could save on this data using auto-coding, but in this year's experience, only classifying 2 variables, if the kitchen is open or separate, and if there exists any of security system utilities, it took 4 people about a full week of their work. So in the future, we would like to autocode more of those variables. For example, we would like to know if there is a balcony and some other amenities in the apartment. So more variables would equal also more time and more mistakes made by our team in making the manual classification. The
Sorry,
result,
Dominic, just to let you know,
yeah.
You've got another minute or 2 minutes, if that's all right.
Okay, I'm going to an end. Yeah, okay.
Thank you so much.
The results on the test set looks really promising, as we have more than 72% of real estate offers classified automatically with accuracy over 95%. I wanted to present some data from BLS, but Inkyong also showed information on accuracy levels of machine learning. So I will step forward from the experience of others. We know that autocoding makes less mistake than human in general. The automatic classification is also less time consuming and gives possibility to put an effort in some other duties. And what is important, the algorithm is repeatable, so it is not as random and as manual classification can be. Well, this autocoding technique can be used to decide whether we want to autocode every description automatically, or we can autocode some of the descriptions that probably have some level of accuracy that would be a threshold, and we would make some part of the set manually, some will be auto-coded by the algorithm. And we can also use those machine learning techniques to provide suggestions for people who can do some classification manually. So to conclude, what we did was brand new for our team. So most of the work were just tests and experiments, checking the possibility of using new techniques. The challenges we met should, I think, only be pushing us to evolve as the statistical system in whole, and as the personnel. For me and my team, the most important experience from joining the ML group was learning new possibilities, encouraging to take part in multiple webinars, to getting in touch with other people involved in the machine learning, reading new methodologies, and also it encouraged us to share information further within Statistics Poland. So I guess that's all for now, and thank you again for the opportunity to share our experience. I hope I have made it in time.
Yes, thank you so much, Dominic, and sorry again to cut you off there. I think we could spend like another sort of extra half an hour or so in your project. It's so interesting, and I think yeah, you make a really good point there about the importance of sort of data preparation and the quality of data that goes into the machine learning application in order to produce good results, and also as well the sort of benefits that can be gained from in this quite experimental stage of machine learning, to be really collaborating widely with other people around the world who are working on similar challenges and issues. So with that, we're now going to go to our final use case, which is looking at machine learning in editing and imputation. And I'd like to introduce Klaus Stamer, a colleague from the UK Office for National Statistics. Klaus is technical project lead, and he's going to talk to you now about a presentation about a project that he worked on as part of the ONS UNECE machine learning group on social surveys. And Klaus, welcome, and over to you.
Thank you, Alison. So my talk today is a high-level overview of a machine learning project that started as a proof of concept of the UK contribution to the 2019 UNECE machine learning project. And Alison already talked about the UNECE machine learning project, and I'm sure that there's more to come as well, because that carried on with the 2021 and now with the 2022 version of that project. So my work was part of the editing and imputation theme on social survey data. And that eventually I developed further into a possible solution for a number of social surveys at ONS. So here are the agencies that were taking part of that first UNECE project. And something I particularly enjoyed was the collaboration with colleagues around the world, and some very productive discussions and work came from that. So we heard early on that machine learning is all about letting the computer algorithm discover rules and patterns that us humans cannot adequately identify from small or big data sets. So let's imagine we want to build a software system that can recognize if a picture is that of a cat. We would have to write down all rules that are needed to recognize a cat, but not just one cat. We want it to be able to recognize any cat. So as humans, we are very good at recognizing things, but we do not know how we do it, and we cannot formulate all required rules to do that well. However, we can let machine learning discover patterns and rules in the data to carry out our classification of the animal pictures. So first we take some of our pictures and we label them with cat or not cat. And then we split them into training data and test data. And finally, we use the training data to train our machine learning algorithm to get our trained machine learning model. And because we created the labels, we call this supervised learning. And because we have two classes, we can call this a supervised binary or two-class classification machine learning problem. To test the model, we take our test data and we pass the test data into our model to get a prediction score. And if that score is above a threshold we have set, the picture is classed as a cat, and if it is below the threshold, it is classed as not cat. And to set this threshold is right at the heart of the business problem we want to solve with ML. And I will come back to the threshold issue later on again. So let's go back to our ML project. To begin with, this was on the living cost in food, the LCF survey income data. But because the LCF income data, together with the SLC, the survey on living conditions, will form the new household financial service, the HFS, this investigation moved eventually to include SLC data as well. So to do this was made possible because both surveys collect income data, and the questionnaire block in the survey have been harmonized. So that means the same questions are asked in either survey. As I said earlier, this project was about editing. First, let us have a look at the definition of editing. It is finding the records that, but not changing the values. So we want to find records that have incorrect or missing data, but this process does not include actually changing the values. And to get this definition right was actually quite important right at the start of our international collaboration. So this project is therefore about finding income records of household members in our surveys that are inconclusive and need value changes or where values are missing. So these 3 surveys have their own individual editing methods, which were historically developed because they were separate surveys. And the living costs in food, the LCF survey, gives us probably the best data once the editing and imputation process has been completed. The data goes through a holistic approach by a dedicated team with some intensive manual editing and manual data imputation process. And because it goes through this intensive process, we can call this our ground truth or golden data set, as it's sometimes called. It is deemed to be perfect. The other 2 surveys have their own specific scripted outlier detection system, which creates a complex set of spreadsheets that point out records and individual features to be manually checked. But on inspection, many values highlighted are kept unchanged. And this work, not resulting in value changes, is seen as a wasted effort. So the aim of all this is to build one editing solution that works for all 3 surveys, but without necessarily increasing the human team that carries out this work. So hopefully it will result in the same size of the team, where this team can work on more data, but focus on the data that need more attention, the tricky data. And because we have the ground truth, I choose to start with LCF income data. And we have, so we can label the data, and that makes this supervised learning. From looking at the edited data, edited imputation data, I found that these 5 features were the 5 most ones that received a change. And then records that had a change in more in one or more in one or more of 5 of these features, of at least 10%, I label them as change and otherwise as no change. And that makes this a supervised 2-class classification machine learning problem. So then I split the data into training data and test data. And I used the random forest algorithm and trained it on the training data together with their respective labels. And this gave us our machine learning model. And this model was then used to predict the class of each record of the test data. And for these, we already know what the prediction should be because we have the labels. And we can find out how well the model can predict records that need manual scrutiny. Early on, I mentioned the importance of prediction threshold. So if we can answer the question, what is good enough, we can set the threshold to meet our objectives. And Eric will talk about this later in the follow-up session. So this table shows a battle between recall, that is our true positives, the cases we want to find, and the precision, that is the ability of the model to avoid false positives. Now, unfortunately, we can never make both 100%, but by lowering the threshold, we can increase the recall, as you can see in the table, but we get an increase in false positives, and our precision goes down. On the other hand, if we increase the threshold, our recall goes down, but precision goes up. But we can find an acceptable compromise by setting the threshold. In this example here, I set it at 35%. So in a production system without ML, all our 2,912 test cases would have been looked at by our human team. But with ML, we can reduce this to just under 600. And that is a reduction of effort by about 80%, while we retain about 90% of all the cases we want to find that needs to be looked at. In addition, with ML, we can retain all the cases that received very large value changes. So this shows that with machine learning, the LCF process for editing could handle about 5 times the number of cases without increasing the editing team. But then I started looking at the SLC, the Survey for Living Conditions survey data as well. But because we do not have a ground truth for the SLC data, only some of the data are manually checked. But the LCF and the SLC surveys ask the same income questions, and because of this, I wanted to find out if the LCF trained model can be used to predict which SLC income data need to be checked. Now, this assumption is based on because both surveys ask the same questions. So the assumption is that the data will be structured in the same way, and the LCF model can make predictions on SLC data, and this we call transfer learning. So here's a proposed SLC editing pipeline. So machine learning, and this blue box here, is used as a filter to remove cases that do not need manual scrutiny before the cases are fed into the scripted outlier detection system. And the benefit of this approach is that the validation team does not have to change the way they work. No software changes are needed for the validation process, and it can be switched on and off when needed. And we can test this because we know which SLC cases were manually checked and received value changes to count how many of the cases we need the machine learning model to pass onto the scripted system are retained. And here are the results. And they actually look very similar to the ones we had for the LCF data. And this shows that transfer learning can be applied. So the SLC pipeline could cope as well with about 5 times the amount of data without having to change the size of the team. These results show that machine learning can make the data editing process more efficient. With ML, the LCF or the SLC pipelines could be used to edit both surveys. So having written the software to train and then analyze the predictive capability of the model, we have to think about putting all this into production. And compared to those challenges, some of them I've listed here, writing the software appears to have been the easy part. So these challenges need to be looked at and they need to be resolved before we can put this into production. And some of this have to be analyzed and kept an eye on during the production cycle as well. And Eric will later on, during the research and implementation workshop, look at all this in more detail. And our technical sessions with Alex will look into how to apply ML and how to do it, how to write the code. Thank you very much. Back to you, Alison.
Super. Thanks very much, Klaus, and for your presentation. Right, we've now come to the end of our use cases from NSOs on the on machine learning, and we are going to now move over to you for your questions and comments. First of all, I'm just going to come to questions online, and then some questions online. Then I'm going to come back to you in the room, and Please be ready for questions. So first of all, we're going to move to Ari. If all the presenters could sort of put their cameras on, so we can see you. First of all, we have a question from Fatima Al-Harbi for Ari, and the question is, Ari, on your presentation, why did you use CNN and not hierarchical classification? Is it cheaper than CNN in terms of resources?
Okay. Thank you, Alison, for the question. Actually, it's a very good question. Why we use the CNN, not the hierarchical classification? First of all, the CNN or convolutional neural networks are the architecture that is designed to distinguish or to extract the feature and recognize the feature in some images. And satellite images is kind of images, so it is the specification of the data that we have that encourage us to use the CNN. That's the first case. And the second one is the CNN architecture is scalable. It means that it is not cheap to use the CNN. However, if you use a large amount of data and you have high performance computing, you will have a kind of a very good accuracy with that. That's something you may not achieve it with another machine learning models. That's the benefit of CNN that we have. Of course, for sure, we know that CNN is not perfect. There are a lot of limitation of CNN, but currently for the satellite images, the classification on the satellite images, CNN, in this case, we use the residual network architecture, ResNet34, is kind of the state-of-the-art of a method that we can use. Yeah, for sure, we can use other kind of machine learning model, but this one is the most suitable for us right now. I think that's the answer from me, Alison. Thank you.
Thank you very much, Ari. And now, if Dominic, you are still on the line, we have a number of questions for you. So we have a question from Rula Abdul Karim, who asks you, what was the algorithm you applied for the automatic classification, and how many data sources, websites did you target? And then we have another question from Christopher, who says, what are the usual software you use for machine learning that is most time and cost efficient? And then another from Ramya Emandi, who says she wants to know if it's possible to do web scrape pricing information for previous time periods and for various cities of a country. So a range of questions there for you, and over to you.
Okay, thank you, Alison. Thank you all for the questions. According to the algorithm we used logistic regression. We used scikit-learn library from Python. So it would be an answer to one of the questions. We worked on Python with libraries from scikit-learn, and now we are working on acquiring next sets of data from other portals. We are working on web scraping 3 other portals. We're using Beautiful Soup, and we are using Scrappy. I know that they have some pros and cons, but for now we are still learning all the techniques, and I guess that the most convenient Python library to web scrape data is beautiful soup, as it is the easiest one for the beginners. But we have some people more advanced, so they work on Scrapy, and the whole machine learning group project led to making one of our colleagues working on next models for the auto coding we did. So for today it was only logistic regression, but I know that he want to apply neural network and some other models to what we did. There was a question on the prices and the previous data, if it is available. So in our case, there was no historical data, but I know that some of the portals provide historical information, but unfortunately, it could be just one portal from the whole bunch of them. And according to the e-commerce information possible to web scrape on food, well, like I said, we started with two of our colleagues working in machine learning group 2019, and they did auto coding of products from online shop. So yes, it is possible, and I guess it could be also the report to be found on the website of the machine learning group. I guess I answered all of the questions. If not, Alison, please correct me.
Thank you, Dominic. We can follow up any other questions afterwards. That's very comprehensive. I just wanted to quickly throw open quick questions, comments to our guests in the room. If you have any questions or comments you'd like to make about what you've heard from our speakers today, then please raise your hand, and I think someone in the technical team will bring you a microphone. Okay, would anyone like to make any comments or interventions? If not, given time, we can move on. But please just raise your hand if you think of a question or comment you'd like to make. So I think we'll just we have a few more questions on the chat, which I will throw open to any of the speakers online who would like to answer. So firstly, did you also check when ML classifications were different from ground truth data, whether the latter was actually coded correctly manually? And also another question, why BS4 was not used for scraping? So I think Dominic, one of those might be, I think that might be for you again. So
yeah.
Over to you.
Okay, so when we did auto coding, we achieved the result of more than 72% of the data set with accuracy higher than 95%, but still there were some mistakes when we checked what the algorithm did. There were in the set of what the algorithm auto-coded, I guess 5% of cases made wrong, but it's all about the accuracy. We didn't achieve 100% accuracy, and I guess it would be really hard to achieve this. But auto-coding should be treated as something that is just a help for a manual classification. Like Inkyong said in the beginning, we can use machine learning not to erase the work of people, but to develop the work and to make it quicker, faster. So in our case, there were also some mistakes in what the algorithm did. Well, I don't remember if it is in the report exactly the number of falsely auto-coded information, but probably there was the information in the report. And why beautiful soup not used for scrapping? Oh, well, we did all the job while preparing our normal duties in the statistical office, so we need to decide to make things going faster. So we downloaded the data through an API. We chose the portal that provided the API connection. But as I know, Beautiful Soup is a little bit or more slower than Scrappy, so it's just to decide what we want to do, what we want to achieve, and what library we will use. Because if we have a small set of data to web scrape, we can use Beautiful Soup. It's easier to write.
Okay, thank you very much, Dominic. That was great. And there are more questions coming in, but I think what we'll do is we'll follow those up separately with you after the session. We will be sharing presentations and further details about our work and the ONS UNECE-ML group with you by email afterwards. And please do look at our website, the links shared there in the chat. If you would like to look further into any of the projects that we've been discussing today. So we're going to wrap up now. So I'd like to thank you all for your attention and your time today, both in the room and online. And also thank you very much to our speakers who've joined us. I know, for many of you also quite early on in the morning in European time. Thank you all for your really excellent presentations. And I will now hand over to Eric to say a few remarks about what's happening next. Just one point I've been asked to mention for those of you who are here in the room is that to attend PCR testing if you can during the break, please. And with that, I'll just say thank you again. And yeah, we hope to see you on our ML22 program this year.
Thank you, Alison. And just to extend my thanks very much to the presenters, particularly in Europe, we had to gather at very early times. So as Alison just said, we're going to take a 20-minute break now, and then we're going to restart our session. So the sessions in this room will be very much available online. So we're actually going to look at coding, which will be led by Alex, and Klaus, who you met online, will there as well. And then upstairs, we're going to start running a research and implementation workshop. It's really to get engaged with you guys and really to extract some ideas around how do you start a machine learning proof of concept. And of course, we start looking at what are the business needs, what are the business objectives. And this is very much what we learned. We learned on that journey by collaboration, by partnering, and also be very open to share that. So again, I want to think big thank you to Alison and Inkyu for putting this event together for us. And of course, we really appreciate for the UE to invite us here and actually do this in person. So thank you again, and we look forward to see you in the next sessions. Thank you.
And also, I've just been informed that we'll be having a group picture right now. So if before you head off for your break, if you would just follow signals from the organisers who will be doing a group photo for those of us here in the room. Thank you, everyone.